this. So in other words, if you that, don't second guess yourself. Calculate okay, guys. Ready? This is the same thing that you've been doing. It's just a little different format, but it is exactly the same that you have been doing. So for you guys that have been catching the areas to the right parts, it's absolutely fine here. We do use the calculator, so if you have the calculator handy, that'd be great. We're gonna find a C-score that corresponds to certain areas. So you do need your calculator for this. If anything else, this one will definitely help with your calculator. If anything else, like this is the one you really need to know the calculator for. You don't like to use it, otherwise that's fine, but this one is good to use. Okay. All right. So we're going to start going backwards. We're going to start going backwards with this. I'm on page 252. Normally, we say, what is the probability that your z-score is greater than 1.2? So you do this. You find me 1.2. You find me your area to the right, right? And you give me a 4-point decimal. You find me your area. This is a little different. We're going to do the reverse. I'm going to give you the area, and you're going to find me the z-score. It's the same difference, and you can use the same table. However, I don't think you would want to use that table, wherever my table is. If you use the table, and they use the table for a lookup, and I'll show you how they do it. I don't use the table. This is the one thing you really need your calculator for. So remember when they say cumulative area means it's coming from the left. It's accumulating from 0 all the way up. So this is area to the left. So if I made me a sketch, would I be looking at a negative z-score or a positive z-score? What would you think? A negative, because why? It's less than 50%. 50% is up to here. This is less than 50%, right? So my z-score is probably over here somewhere. I need to find that z-score. Now what they do, and that was good, and you kind of know this with your table, you take out your table 4, you notice your negatives go from 0 all the way up to 0.5, right? When you put the 0, from negative 3.49 all the way up to the 0. That's when your area is less than 50, which makes sense. If it's a positive, your area starts at 50 and goes all the way up to like 99999. And technically never hits 1, but close enough. Okay, so now, they look at the table. If you look at page 252, they look at the table, and in that big mix of stuff, they're trying to find this number. You good? Probably did better than you think. So you notice where they find 0.3632? Then they back it out to find the z-score. So negative 0.35 is their z-score. Everybody see how they got that z-score? They took table 4, they looked in the big part, in all the decimal parts, to find this value, 0.3632. I know it's less than 50%, I know it's a negative. So I look for it. Sometimes you're not going to find the exact one. You need to find one close to it. So you're going to have to call it extrapolate. You're going to have to figure out where your z-score falls. There's a nicer way to do this, and this is on your calculator. So if you grab your calculator, and remember we've been looking at second VARs to do all this stuff. Down to number 3, it says INV norm. This is inverse norm. This is find me the inverse part of your normal curve. Normally we say give you a z-score, you find me the area. This one says I give you the area, you find me the z-score. So when we come down to this, it says my area is 0.3632. I'm on a standard normal curve. I just want to find my z-score. I paste. And there's my z-score. I have to round. All z-scores should be rounded to 2 decimal positions. So negative 0.35. You bypass having to look up in that big part of that table, because that's annoying to look that up. Sometimes it's not so bad. Get a feel for less than 50, more than 50, and at least you're on the right side of the page. But you can put this in your calculator very easily. Second VARs, inverse norm. If anything else, this is the one part you'll use on your calculator. Put your area in, and it finds you, use your standard normal curve, 0 and 1, and it finds you your z-score. Okay? Let's try another one. Okay. Find a z-score that has 10.75% of the distribution to its right. So automatically I'm panicking. 10.75%. Panic. I never saw this before. 10.75%. Usually I see my numbers in 4 decimals, so move the decimal over. Don't we take our z-scores, find our areas, and then we flip them 2 places over to make a percent, right? We're backtracking, we're doing everything backwards now. So I want an area to the right, there's my 0, to be 10%, 0.1075. So this is a small amount, right? So somewhere over here to the right of my area is very small. What's this area to the left? What's the area to the left? If I subtract from 1, right? Is that right? Did I subtract it right? Probably not. 0.8925, I wasn't even close, huh? 8925? 0.8925. Okay. This is my area to the left, isn't it? My whole curve adds up to 1. I want my area to the right now to be this little small part. So my area to the left is this. I still need to find that z-score. So I look at my table for this guy. It's bigger than 50%, so shouldn't it be a positive z-score? So I look on the positive side of my chart, and they do find it in the chart. They find 0.8925, and they bring it back out to a z-score of 1.24. So we're going to use your calculator. We're going to say, let me just put this, second VARs, inverse norm. Now, I already subtracted it from 1, so I'm going to use this number. Standard normal curve and a piece. And there's my 1.24. However, because I didn't do a very good job subtracting it, I don't want to make a mistake. So I'm going to let my calculator do the subtraction. I'm going to say, why don't you subtract this for me? 0.1075. You subtract it. I don't care what the area is to the right, to the left. I need to look up my area to the left. But I don't care what it is. I just know this is my area to the right. My whole area adds up to 1. So when I look it up, I just need my area to the left. Just tell your calculator to subtract it. And you still get the right answer. It subtracts it. Don't make a mistake like I did and then put the wrong number in there to get the wrong z-score. The bad part about the calculator is, once it's done, you can't say, oh, did I put the right number in? What did I put in? You wrote over it, or did something else, or cleared your calculator. So that's the bad part about the calculator. Can you use the table? Absolutely. Okay. Kind of getting what we're looking at? We're doing just the opposite. Normally I give you a z-score. I say find me the area to the right or to the left. You give me an area. This time I'm giving you an area, and I'm telling you, is it to the right or to the left? And you need to find a z-score. We always look up z-score from the left. That's a cumulative area from the left. So I want you guys to try it once, not two. I just want you to try. So wherever I put my z-score, it has to be more than 50% of it to the right. Agree? So Riley says it'll be over here. It'll be a negative. So that this part has 96% of my whole curve. This is 50% in the middle. So I need to come over to this side, to the right. So again, they look a little strange, but I'm going to move my decimal point. I need to find the z-score that corresponds to this area. So I have two choices. I could look it up in my table and hope I find the exact z-score, or better yet, I could use my calculator, second varies, inverse norm. I'm giving it the area to the left to look this up, not the area to the right. I'll show you what happens if you do the area to the right in a second. So since I need to give it the area to the left, what should I say in this part under area? I need to tell it the area to the left so it can find the z-score. 1 minus this. Let your calculator do the subtraction for you. We're a standard normal curve. I paste and I find my z-score of negative 1.77. Now, say I make my sketch. I know my z-score has to be negative, but I come here, and when I get to inverse norm, I just put in 0.9616. Because I'm thinking area, big chunk of area. I come down here, I paste, and look what I get, 1.77. How did I get 1.77? I really wanted the negative. Why did I get 1.77? I didn't subtract it from 1. Isn't your curve symmetric? So this area over here is the same as this area over here. And this area to the right is the same as this area to the left. Right? So if I didn't do it, I could still look it up. I could still get the number that I need, 1.77. I just have to make it negative, because my curve is symmetric. The one thing you have to do is always look up and write this down somewhere. Always look up, put it on your note sheet, area to the left. If not, if you looked up the area to the right, it's okay. You're just going to have the opposite sign on your z-score. So your sketch is going to say, oh, it's symmetric. All I got to do is take the sign, change the sign on that. Everybody see why we did that? This is a hard concept to get, but once you get this down, there's nothing to this. Now this one's a little trickier, the bottom part. The bottom part says, find the z-score for which 95% of the distribution's area lies between a negative and a positive of the same z-score. In other words, remember when we do this? And we do plus or minus 1? This is my favorite. And we say 68% lies between plus or minus 1 standard deviation, right? Okay, now I want to know what percent, what z-score, do you remember this? Has 95%. Remember this? I always sound like a broken record with this. It's plus or minus what? 2%, right? Isn't this the empirical rule? Isn't plus or minus 2 standard deviations 95%? And what is plus or minus 3 standard deviations? 99.7%. But you know, I can't remember this all the time, so I'm going to figure this out using my inverse norm and find this z-score. Because if I can find this one, isn't this one the same but a positive? Okay, so if this piece in the middle is 95 and my whole curve adds up to 100%, then these two parts have to add up to 5%. Agree? So I need to look this guy up from the left. So I just need this little part right there. So since I have two the same, if I take this and divide it by 2, this is 2.5%. This is 2.5%. So can I just look up the 2.5%? But I need to switch that to a decimal because this is a percent. I'm going to move this 2 places. I'm going to look this up in my table, or I'm going to do an inverse norm. So I do inverse norm. Your calculator's a little bit more exact than we are. I'm looking at 0.025. I don't need the 0 at the end. And I get negative 1.96. We said plus or minus 2. If you use plus or minus 2, that's fine, because remember the empirical rule rounds it. Remember, we weren't exact with the plus or minus 2, but that was, they give us for like a rounding part. Negative 1.96, positive 1.96 are the exact values for that. Now, your calculator is so smart. It could say, okay, what you wanted to do, you wanted to, parentheses, subtract this from 1, right? And then you wanted to divide it in half. Agree? Because I subtracted from 1, I got the sum of those two parts. But then I just wanted to divide this in half because I wanted to divide this in half because I only wanted the left-hand side. Tell your calculator that. We didn't have to do all those. Your calculator can do all this. And I paste, and I get negative 1.96. This is the trickier one. All right, let's try another one of these. Let's say I want the z-score for which 80% of my distribution falls between negative z and positive z. So again, here's my curve, it's symmetric. I want a negative z and I want a positive z, and in here I want this to have 80% between those two. What percent is left of my whole 100%? 20. And these two little pieces have to share 20% equally, don't they? So I'm 100 minus 80, which is 20, and I'm going to divide that by 2. Each one of these pieces is 10%. So all I have to do is do an inverse norm on 10%. Or an inverse norm and let it do what I did. But remember, you need parentheses for order of operations. You need 1 minus 0.80 divided by 2. If you don't use those parentheses, it's going to do the 0.80 divided by 2 first, because it goes to division or multiplication. And then subtract it from 1. And you need to put everything in decimal in the inverse norm. So let's put it in inverse norm. Let's let it do all my calculations for me. So I'm coming down here. I'm going to say 1 minus 0.80. Divide that by 2. And paste. And this is my negative z-score. This is my positive z-score. So between these two z-scores lies 80% of your data. Another way to check this is take the negative 1.28, find the area, take the positive 1.28, find the area, and subtract your areas. That'll be about 80%. We have a little rounding going on, so it's never usually exactly unless it came out to a terminating decimal. But your calculator is real good about finding those things. Good? I'm having you think in reverse. I'm having you think backwards. Okay. Now, sometimes we're given a percentile, and we're asked to find the z-score that goes to this percentile. Where does your area accumulate from? Which side? The left. So your area accumulates from the left. And we talked about how you're ranked, how you accumulate your percentiles. So if this is our z-score in the middle, our areas go from here to 100, right? So if we're looking for a percent of 5, that means we want to come from the left 5%. So we want to just cover 5% right here. I'm in the 5th percentile. I didn't do very well on my scores. I'm in the 5th percentile. There's not a lot of people I'm better than, right? So I find out what my z-score is. I do an inverse norm on 5%. And if you want to, you can always look it up into your table. Remember, your inverse norms have to be decimals. You have to be able to just move the decimal 2 places back and forth. Percent to decimal, move it to the left. Decimal to percent, move it to the right. So I want to tell it, I want 5% to my left. Keep your 0 and 1. My z-score is negative 1.64. Shouldn't I be negative, right? According to my chart, shouldn't I be negative? I wanted the area to the left. 50%. If you want 50%, what's your z-score? 0. That would make sense, right? 50% of my curve is right here. My z-score is 0. 90%. Give me an estimate. What do you think your z-score should be? Just wing it out there. Doesn't have to be just like in the ballpark. Two, 1.7, 1.9. Should it be 3? It's too far out there, right? That's real small. Even 2, but 2 is a good estimate, right? Somewhere out here. 90% of my curve to the left means way out here. If I'm in the 90th percentile, aren't I way up here? I start from the 0. Don't I want to be ahead of my class by 90% of that class? This is 90% of my curve right in here. Kind of think ranking, because that might help you think percentile. If you're ranked in the 90th percent, you're better than all those kids in your class. That's got to be a large area. So again, inverse norm, 0.90. There's no subtracting anything here. Inverse norm, 0.90. And we want to come down and see what we get. And we get 1.28. We get a z-score of 1.28. We knew it was going to be pretty much up there in the positives. Just kind of wing what you think it's going to be, just so that you get a reference for where you're going to end up. Okay? You guys, try this. Try to find me your areas. Please try. So again, let me make one sketch for this. I'm looking for 10% of my curve. Where am I finding that? Where'd you find it, Gal? On the left, on the very left, right? I want this to say 10%. So what'd you get? What'd you get for your answer, for your z-score? You can't do the inverse norm. Okay, I'll show you how you can do it. You can? I'll show you in a second. Okay. Without even using your calculator, could you get the answer for this? Did we do one that could help you out a little bit? Miranda, you see it? Negative 1.28. Oddly, this was positive 1.28 when I wanted 90% of my curve to the left, right? Isn't this symmetrical? So isn't this also 10% out here? So if I found the positive, couldn't I find the negative to that using the same concept? But inverse norm, if you didn't get it, inverse norm. But you see how symmetry works in this? 10% on this side, 10% on that side. The z-scores have to be the same, just one's a positive, one's a negative. Okay? 20%. 20% to my left, I'm still not 50%. Oops. I'm still not 50%. Okay? I'm going to do inverse norm 20. Again, come down here, inverse norm 20%. Paste. And you get your negative, remember z-scores, 2 decimals. So I want you to round that. So this has a z-score of negative 0.84. And the last guy, 99 percentile. What do you think this should be? 1.5, 2, 3, kind of a little bit way past there, right? Because 99% of your curve sits there. So inverse norm. I'm coming from my left. 99% of my curve. It's almost the whole curve. We know it's a little deceptive looking. So 2.33. And that makes sense? Now, on the black calculator, you can still use inverse norm on the 83s. You can still do inverse norm. You just have to put this in. So, can I borrow yours 1 second, Cal? You have to say the area, comma, 0, and 1. You have to say this. You have to say your area. Give me your area that you want to put in, comma, 0, comma, 1. This tells it it's on a standard normal curve. So in other words, for this one, I would say inverse norm, 0.99, 0 my mean, 1 my standard deviation. And that will give you 2.33. Give it a try. It works the same way. You just have to string out those things instead of get prompted for it. I can't change the 83s, only the 84s. Yeah, but you can string them out. It's kind of nice. It's just give me the area. I don't know if it does the 1 minus. If you do like a 1 minus in there, you need a separate parentheses. I still think it'll do that, but you need a separate parentheses. Good? Questions? All right, I'm going to give you some of these to try. Page 257. 258, 1 through 29, odds. I want to make sure you get this part. You don't have to take this home. You can probably do this tomorrow. Cover the first 15 minutes. Happy, okay? We'll do like the first 15 minutes of tomorrow, and then go over it. I need to make sure you get this part down before we go do anything else. And then we'll start the other part. It's just transforming your equation and using this. calculator and inverse norms, if anything else, nothing else, that's the one you should use it for. The table is a nightmare to look up those numbers, especially when you don't find it exactly.